Stuff is broken. Okay, let's see if I can get him to.
Oh,
There we go. Hello. And let me put you in. Make host, the recorder is running. So you are free to go. Pretty much just like this morning, same lab. And the victims have been prepped appropriately.
okie doke. As soon as Anaconda decides it wants to cooperate, we'll get started. Okay.
Cool. I'm going to mute myself.
Okay, is everyone able to see my screen and hear me? Alrighty. Well, I've been grading most of the day. I'm almost caught up for this class. I think the other class is caught up. So I'll be finishing that up later. Today is going to be one of those library labs, meaning we are going to spend most of the time seeing some features from the library, see what it can do. Before that, here's what I'll do. I just got through with the 7th, which involved a screenshot. Let me see. This should work. And this is another thing I've noticed in the lab, or not the labs, the office hours, is that a lot of people don't know how to take a screenshot. Okay, well, we're going to fix that because it's a very important tool to learn. There's a button on your keyboard. It's above it's up and to the right of the backspace. If it's a full-size keyboard, it says print screen. That's one way to do it. If you do that and then paste with Control V, it will put your screenshot into wherever you're typing. So I usually open Paint if I want to do it that way. But what I prefer to do on Windows is there's this thing called the snipping tool. So I start, search, snip, and there we go. This is the one I like to use. How do you use it? Well, press the new button here. And there's a ton of tools that do this. I don't know them off the top of my head because this one works fine for me. And as you can see, it won't be around in Windows 11 or whatever. But you click the new, and then everything has gone kind of a translucent color. I select where I want my capture to be, and then I either save it or copy it. If I copy it, I can paste it wherever I want. In fact, pretty sure I can go in here and do this. So we have Labception. But yeah, that's how you take a screenshot. Very important. You'll be using that a lot. Okay, so back to the actual lab. One moment. It is very cold out, and normally I would just leave the dog, but it's very cold. And she's old. Okay. So what is Matplotlib about? It is about visualizing data. Visualizing data is likely going to be, if you pursue a job in data science, likely going to be the biggest part of your job. Because even amongst people who know what you're talking about, it's difficult to look at a data frame and see a pattern from it. And especially for people who don't know what you're talking about, usually your boss is going to say, here's the data from the latest whatever. I want you to show increase of blah, blah, blah for my next presentation at lunch or whatever. If you hand your boss a data frame, they're not going to be employed very long. What they're going to be expecting is something visual, some kind of plot, generally, a bar graph, a chart, pie graph, whatever. So that's what we're going to be using Matplotlib for. Now, there are a bunch of explanations here that are straight from Wikipedia. In fact, I mean, like it actually says that. I'm not just making that up. Like, yeah, right here. So I'm not going to spend a whole lot of time reading what's actually mentioned here. But if you're curious, you can go ahead and look. So the first thing we're going to look at is what's called a bar graph. Now yours should start out like this. I don't remember if the width is set it was 0.4 or not. So what are we going to use a bar graph for? Well, if I have a collection of things that have a number to them, but the things themselves don't particularly have that much of an order, and generally, if there aren't that many of them, bar graph seems appropriate. If I have 50 things, maybe I don't want to use a bar graph. I've seen some that have quite a few, but generally we'll just keep it simple. All right, so I'm going to go ahead and run this, and so we can see what it looks like. So we have a bar graph where on the x-axis we have the flavors of ice cream we have in storage, and on the y-axis we have the number of cartons. So as you can see, we have 16 of the chocolate and 5-ish of the strawberry. The important part is we can easily see we got more chocolate than the other two, even combined, and we're running low on strawberry. Quick, easy, all it takes is a glance. I don't need to look at numbers or anything. You can change, so here's the part that is the most important one for making our bar graph. You can change the color, you can make the width different. You can do pretty much whatever you want. Whole bunch of options everywhere. Let's mess with one of those options. Let us make the, before we get into more options, notice how I'm using matplotlib.pyplot.bar. Well, that gets kind of to be a pain. So what we're going to do is we're going to assign a nickname to this, and we're going to call it PLT. So how are we going to do that? Right here. When I import this as what I'm interested in using, what I can do is say import that as something. And I'm going to import it as PLT. So from now on, I can just use PLT. So we're going to do the same thing we had before, except we're going to make it orange. And the difference being we're using our nickname instead of this. All right. Again, you can make the bars as large or as wide or as thin as you like. Change the color to any of the preset colors. Or if you want, you can put in a hex color. A hex is 6 digits. So 1, 2, 3, 4, 5, 6. I have no idea what this will be. It's bluish. In fact, it's very blue. The label of the X is here, the label of the Y is here, and there's a whole bunch of options you can mess with. Well, that's all well and good. How did we make this bar graph? Well, we started with a dictionary, and then we made some lists from our dictionary, and then we called stuff on them. Well, I know a much easier way to do it. So let's make a data frame. So I'm going to make a data frame out of my dictionary. I'm going to call it DF. Here's what our data frame looks like. It's actually the entire thing because there are only 3 rows in our data frame. And then this is it. The data frame has a plot function, and part of that plot is bar. And there we go. We can make it horizontal if we like. Just ignore that. The error, it shouldn't, I don't even think that's there in your example. We can, let's see. Oh, that's in the next example. All right. All right, here's another example. We have students taking classes in programming courses. So the ones offered are C, C++, Java, and Python. And we have a corresponding number for how many students are taking each. All right. Well, here's the dictionary encoding that. And we're going to do the same thing we did before, and we're making a bar plot out of the whole thing. All right, here we go. So is this appropriate for a bar plot? Yeah, I kind of think so. There's no specific order to any of what the courses are. I could mix them around, and it doesn't really matter. We can even make it horizontal if we like. So your job as the data science person is picking the visualization that's going to work the best. And I'll have an example here in a bit of a making the wrong choice. So has anybody got any questions on the bar graph section? It's pretty simple, so I don't expect that to be the case. All right, well, let's move on to the next one, which would be a line chart or a line graph, whatever you want to call it. What is a line chart good for? Well, when you have points on your plot, this and then this. When you've got your plot, whatever, and you've got points that have some kind of pattern to it where you can somewhat draw a line between them, then maybe a line chart might be the one you want to go with. Picking the right one is as much an art as it is a science. So let's take a look at what those might look like. So here I've got a time elapsed versus speed kind of relation going on. I'm going to store that into lists, and we're going to plot it as a line. Now, I don't remember. I might be able to. No, I can't. I don't remember exactly how this started out before I started messing with it. You can change the color to whatever you like. Additionally, you've got some options here. I can make this marker. There's quite a few things you can make it. You can put an O, it becomes a circle. You can put a V, it becomes like a upside down triangle. Although I suppose a triangle can't be upside down. I know there's at least two more, but I can't really think of them right now. Maybe this? Nope. We can mess with the line width. We can make the line width as small as we like. Or if we want to, we can make it quite thick. In fact, I did this earlier and it got silly. Every time I make to where the whole thing's just filled up. So how does it work? Well, we plot the time as the first argument, since the x-axis, y-axis, and then these, I believe, are optional. I think it'll work. Yeah, it does. Okay, so what do we have here? We've got this isn't actually a curve. This is a line with no curve to it between each point. We don't actually have a formula that does what we want here. So let's try to do that. Let's try to add a linear fit. This is what we did last lab, I believe. So what am I going to do? I'm going to take our y equals mx plus b kind of formula, and I want to get a line on here that I really need to move this over here. There we go. And I would like to get a line that, you know, minimizes the residuals like we talked about last time. I want a good line is what I want. So let's see what we can do. We'll do this. Here is our line plot, and the blue line is the thing we're trying to approximate with. Is it okay? Yeah, it's okay. I mean, it's not like this or anything, but we could do better. How can we do better? Well, we can change the slope and the intercept around. So I think this starts at like -10. So we set the y-intercept to be way down here. And what that does is puts a line kind of down through here. Is this better? I don't know. We know how to find out. Someone give me a intercept and a slope that will be better than this. At least you think it will be better than this. Think about what you want to do with the blue line, and then give me a slope and an intercept that'll do that. Zero intercept, slope is x squared. I don't know if that will work. In fact, I know it won't, because the slope is a coefficient, meaning it's just the m in front of the x. After all, this is a linear fit. How do we know it's a linear fit? Because this is the function we're using. I can change it to be a quadratic fit, and I will here in a second just to show you, but this is actually a linear fit. But you say make the y-intercept 0. Okay, we can do that. To make the y-intercept 0, we have exactly what we had in the first example. So somewhere between 0 and -10 might be a little better. So let's try -5. It goes right through kind of the middle. Is it better? I don't know. We'd have to actually measure the residuals to find out, but seems okay to me. Now, if I actually wanted to make this a quadratic fit, it's pretty simple. Here's my coefficient for slope. Here's my coefficient for intercept, and here's my x. All I have to do is go. Actually, that will that work? No, it won't. I think that's what I have to do. Yeah, but that's good thinking. I like it. All right. So that is a line plot. The red one is a line plot. Let's take a look at the idea of a scatter plot. What is a scatter plot? Well, it's just like a line plot, except there's no line between the points. And I'll show you here in a moment why one might be good and one might not be. You can easily make a line plot into a scatter plot by making the line width 0. Now there's no line there. Now it makes sense to make this a line plot because, well, there's a quickly visual relationship that putting a line between the points in order makes sense. But if I have something like this, so here's my plot and the points on it, there's a general trend to it. You can see there's a positive correlation going on here. And what that means is that in general, these things trend upward. But if I were to draw a line between each point, it would look like this. And no one wants to see this nonsense. So in this example, it probably wouldn't be great to put the line there. We kind of just want the points. That is what's known as a scatter plot. Why is it called a scatter plot? Because the points are scattered all over the place and they're not connected. So we can do that. You should have a CSV. This is, it was provided. What it is it's the relation between the height of the parents and the height of the child that was just measured. There wasn't any particular reason in choosing the first parent-child couple or the second one or the third one. You could randomize them all up. It looks like this. I could jumble these up if I want. Doesn't really particularly matter which one's highest or smallest. There's no order to them. So because there's no specific order to them, the idea of using a scatter plot is probably going to be nice. So here's kind of what our data frame is going to look like. We got the father's height, the mother's height, and I think the child isn't actually, I don't think the sex was written down. So in later examples, I just showed that way. So let's build some lists. Let me change this to, I think, it's not terribly important. I'll just put it back the way it was. Okay. So here's a scatter plot relating the height of the child and the height of the father. Okay, cool. You can see that there is a trend here. As the height of the father goes, well, I guess this is the son. As the height of the son goes up, the height of the father tends to go up as well. But if I were to try to make this into a line plot, it would look kind of silly. So instead of that, I'm going to do this. Say son, dad, red. All right. Now, does that line do you any good? Doesn't look very good to me. Looks kind of silly. So this is one of those cases where you don't want a connection between the actual points. We can do more. We can actually put, oh, I still have that from earlier. As I said, if you make a line width equals 0, you've got your scatter plot back. So here we have the plot for the father in red and the plot for the mother in blue superimposed over each other so that we can see that there is a positive correlation, meaning it goes in this direction, for both the mother and the father. So basically, you can see that there's a relationship saying the taller your parents are, in general, the taller you will be. So this is an example of something you would want a scatter plot for. I can't really think of, there's no real relationship between any particular measurement. So that would be parents 1 and child 1 versus parents 6 and child 6. There's no real order to them. You could jumble them up if you want. So scatter plot's pretty good. And this is just showing how you can do it with the data frame. Oops. Data frames are nice. They're a lot, they behave well with the other libraries. Okay, so before I go into histograms, are there any questions or even better things people would like me to change about any of the line or scatter plot stuff? If you want to make your picture bigger or smaller, you can do that by using the figure size argument. So if I make it like this, it'll be teeny tiny. If I make it like this, it'll probably be off the screen. Yeah, it's too big. The plots are there, they're just small. Okay, let's look at what a histogram is. So a really good way, remember how we had the bar plot before? This is going to be very similar to that. Instead of having one bar for every kind of flavor, we're going to group flavors together. Now, it doesn't actually end up being just flavors. You can group anything together you like. What we have here is a CSV that we're going to make into a data frame for data about movies. So we see the studio that made it, the income, gross, adjusted for inflation, and the year it came out. So what we're going to do with that, first thing is we're going to put it into a data frame. And I actually sorted it here so that you can see the range that this spans in years, and it's almost 100. And so what we're going to show is grouping these movies up by the amount they make, and this is tens of millions of dollars. And by default, there's 10 bins that these go into, which lines up pretty well with 94. It's pretty close to 100. And so what this means, I've got a bin for 0 to 10 million, 10 to 20 million, 20 to 30 million, so on and so forth. And every time I look at my movie, I'm going to say Avatar. Okay, this made, it's hard to tell from all these. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this goes in the 8 bucket. This one goes in the 10 bucket. It's actually the 11. This one goes in the 7 bin, and so on and so forth. We do that for everything, and you can see that somewhere around 40 movies made 0 to 10 million. Now, what I can do, there's an argument here for bins. And if I make this the number of actual movies there are, It just turns into a bar plot, bar graph. But this isn't very super useful because everything has its own individual bin. And what we're wanting to do is kind of link things up together. So I'll take this back to, I don't know, 9. And we can see kind of like it was before. 10's the default. And again, this should have all the same arguments. I can set this to whatever. But the nice thing is, or a nice thing, we can group these up by whatever we want. I can pick any column. I can say gross. I can say studio. Let's group them up by the year. So what do we see here? That most films, at least the ones that we have the data on, are somewhere in to the left of 50 million. And then we got some breakouts here in the above 50 million. What is this one showing? This is grouping them up by year, showing the amount of films that came out from 1920 to like 2015 or so. As you can see, they go up. What more can we do with this? Well, what your job is going to be is you want to be able to visualize patterns well. So maybe changing the bins from 10 to 5 will let you more easily see that it is for every breakout movie that gets over 80 million, you've got 60 ones that don't make it that far. We can also change the column name to check for, I think there was a space, adjusted. You can see if we adjust for inflation, that relationship even gets worse. So almost all movies are in the are in this area. But yeah, there's a ton of arguments that you can tinker around with and change things with. Change the column you want to look at, change how big you want the figure to be, change the color. Heck, I don't even know them all. I'd have to look them up in order to see what more we can do. But generally, the idea is if there's a particular thing you want to do, there's a way to visualize it. And as long as you don't mess with the data, just representing the data in any way you want, pretty much something you can do. Okay, so the take home or the homework is everything I did, you're basically going to be doing it. Here's something for line plots, scatter plot, doing a line fit, try to make your fit better, using a data frame to do it, scatter plot, bar charts, et cetera, et cetera. So everything I did, you're just gonna be doing it with different data. So now's your chance before you have to go do it on your own and you don't have anyone to help with to ask whatever you'd like. Over any of this stuff. Visualizing data is very important. And we're going to be doing it pretty much the rest of the course. Just like we're using data frames everywhere, we're going to be visualizing with plots. Do we answer the exercise at the bottom of the lab? Yep. Yes, you do. Selecting the number of bins is important when working with histograms, as you saw. If I change this to 94, it's not exactly the most useful thing in the world. It's just a bar graph. So the question would be, are there any rules or recommendations for choosing the number? What happens if we use too many or too few? The question is, since matplotlib is imported at the beginning of the take home, no, every cell is technically part of one big program. So you don't have to import it every single time unless you want to. If you want to change the nickname, yeah, you'll have to. Anything else? And you'll notice that this is a kind of a question and answer cell, not a code thing. Well, okay. If that's it, then that's it. That's matplotlib. So, if you need any help, just email me.